Hello students, welcome to my YouTube channel Dear Mathematics, and also welcome to the chapter of differential equation. From the last 2 or 3 videos we are just moving through the phase of first order first degree differential equation, and also in the last 2 or 3 videos we have solved or we have seen the different types of methods that we are applying to solve a first order first degree differential equation, and we have seen there total 6 number of methods are there to solve a first order first degree differential equation, and also we have discussed totally about the first 2 types methods of the first order first degree differential equation. So we have already seen that the first method was dy upon dx is equal to f of x. That means the first order first degree differential equation was in terms of x only. The variable was here x, and the second type method was dy upon dx is equal to f of y. That means the first order first degree differential equation is in terms of y only. That means the variable will be y only, and we have solved some of the problems that are based upon the 2 types of methods. But in this video we are going to discuss about the third method to solve a first order first degree differential equation, and that method is variable separable method. So first of all, see what is variable separable method. So the third method is variable separable method. So the definition is there in the term variable separable, because we have to separate the variables only. That means first of all we have to separate the variables, and then we have to go for the integration. So if the differential equation can be put in the form of f of x dx is equal to g of y dy. That means there are 2 types of functions, one is f of x and another is g of y, and the f of x function contains only x variables, and the g of y is such type of function which contains only y variables, and they can be separated according to the dx operator and the dy operator, and then we can integrate both sides. So whenever we can separate the f of x and g of y, we can say that here we can say that the variables are separated if any differential equation can be put it into the form of f of x dx is equal to g of dy. That means they can be separated along with their operators. Then in that condition we can say that the variables are separated. That means f of x function is such type of a function which contains the variable in terms of x only, and the g of y is a function is such type of a function which contains the variables in terms of y only, and they can be separated, and in that case we can say that the variables are separated. Now after the separation of the variables along with their operators, we can move through the integration process. Then integrating both sides, we can get the general solution in the form of after the integral of both sides, we can find out the general solution in the form of like this way, integrating both sides, f of x dx plus any constant c. In the problem part there will be no question of, in the solution of the part there will be no integration sign, because we would have given some of the functions here and we can integrate them. So there is no question of integral sign in the answer part of the given differential equation. So here it is the definition, so there exists any integration sign, but in the problem part we can integrate both of the f of x function and gy function with respect to x and with respect to y, and then we can find out the general solution in this form. So this is the fundamental behind the variable separable method. So this is the third method to solve a first order first degree differential equation, and you can use it in your problems. So let us see some of the problems that are based upon the variable separable methods. So here it is the first problem of the first order first degree differential equation, and we have to solve it by using the variable separable method. So let us First of all, we have to separate the variables to the corresponding sides of dy and dx. So it will be in the form of 1 upon y dy is equal to 2x divided by x plus 1 dx. Okay, now the variables are separated towards the two parts of the equation or two sides of the equation, and then we have to move for the integration of both sides. Integrating both sides, we have integral of 1 upon y dy, it is integral of x upon x plus 1 dx, and then 1 upon y dy, it is 2 x plus 1 minus 1 divided by x plus 1 dx. Just we have added a 1 and subtracted a 1 in the numerator part. Then it will be 1 upon y dy, it will be 2 integral of x plus 1 divided by x plus 1 minus 1 upon x plus 1 dx. It is 1 upon y dy, it is 2 integral of 1 minus 1 upon x plus 1 and its integral with respect to x. Then just separating the right hand side, we have integral of 1 with respect to x minus integral of 1 upon x plus 1 with respect to x, and then by using the appropriate formula of the integration, we can have log y is equal to 2 whole into x minus log modulus of x plus 1 plus any constant c. So this is the final solution of this problem. So first of all, we have separated the variables to the both sides along the dx and dy, and then we have integrated both sides, and then we have used the appropriate formula of integration. Then let us move towards to the next problem of this session. So here it is the second problem of this session, and it is given that cos x 1 plus cos y dx minus sin y 1 plus sin x dy is equal to 0, and it is clear that it is a first order first degree differential equation. Okay, first of all, we have to separate the variables. So first of all, let us convert this equation into cos x divided by 1 plus sin x dx minus sin y divided by 1 plus cos y dy is equal to 0. Okay. How it comes from this equation, let us see. Cos x 1 plus cos y dx minus sin y 1 plus sin x dy is equal to 0. Let us divide 1 plus cos y and 1 plus sin x to the both sides of the above equation. That means we have to divide this side by 1 plus cos y and 1 plus sin x, and also similarly in the right hand side also we have to divide 1 plus cos y multiplied with 1 plus sin x. Then just separate this equation, and it will become cos x 1 plus cos y whole divided by 1 plus cos y and 1 plus sin x. Then this part becomes sin y 1 plus sin x whole divided by 1 plus cos y multiplied with 1 plus sin x dy is equal to 0. Then just cancelling the common parts from both numerator and denominator, we can have cos x divided by 1 plus sin x dx minus sin y divided by 1 plus cos y dy is equal to 0. And this is the separable form, because we have separated the x functions and also we have separated the functions containing y variable, and we have kept near it to dy, and here the function f of x is kept near the dx part. So this is the procedure how we can define the second step from the first step. So this is the procedure. You can also write down those steps, how we can directly evaluate the second step from the first step, just by dividing 1 plus cos y and 1 plus sin x to the both sides of left hand side and also right hand side, and then just separating and then cancelling the common parts from numerator and denominator, we are getting this step, and then we are going to solve this. That means we have to integrate, but before that let us take another step here so that it will be easy to integrate us. Plus just shifting the negative sign to the sin y. Let integrating both sides we have and the integration of 0, it is a constant, and I have already told that you can take constant as c, c1, c square, log c, anything you can take in the place of constant. So here we have to go for the substitution method, and we have to apply the substitution method here. So let 1 plus sin x is equal to t, then cos x dx is dt. Let 1 plus cos y is equal to p, then minus sin y dy is equal to dp, and then we have to use these substitutions in this previous step. Let us see what we are getting here. We are getting just integral of 1 upon t dt plus integral of 1 upon v dp, and it is log c. Then the value of integral of 1 upon t with respect to t, it is log modulus of t plus log modulus of v is equal to log c. And then again by putting the value of t and p here, we are getting log modulus of 1 plus sin x plus log modulus of 1 plus cos y is equal to log c. Then just simplifying the step, we can have log 1 plus sin x 1 plus cos y is equal to log c, because we know that log m plus log n is equal to log mn from the logarithmic chapter. This property is used here, and then cancelling both sides, cancelling the logarithm of on the both sides, we can have the answer now. It is 1 plus sin x modulus of 1 plus sin x multiplied with 1 plus cos y is equal to c, and this is your final answer, and this is the general solution of the given differential equation of the first order and first degree. Then let us move towards to the next problem of this session. Then coming towards to the third problem of this session, and the problem is like this: x square x tan y dx plus x square y tan x dy is equal to 0. So first of all, separate the variables. Then this will be x square x tan y dx is equal to minus x square y tan x dy, and then shifting the y function here tan y towards the right hand side, because dy in the right hand side, and then in that step also we have to shift the or we have to change the side of tan x, and we have to bring back it into the left hand side. So it will be sec square x divided by tan x dx, and it will be minus sec square y divided by tan y dy, and then we have to go for the integration of both sides. Integrating both sides, we have and then we have to use the substitution method. Let tan x is equal to t, then sec square x dx is equal to dt, and here let tan y is equal to p, sec square y dy is equal to dp. Then we have to put these substitutions in this step. And here it is, log modulus of t is equal to minus log modulus of v plus log constant, because in place of constant you can take any form of the constant. Then it will be in the form of a log. In the place of t we have to put log tan x is equal to minus log modulus of, in place of p we have to put tan y, and it is tan y plus log constant. And then just shifting this term toward the left hand side, we can have log modulus of tan x plus log modulus of tan y is equal to log c. And then applying the property of logarithm, we can have log tan x plus tan y is equal to log c. And then cancelling the logarithmic from the both sides, we can have the final answer or the general solution of the given differential equation tan x plus tan y is equal to c, and which is your answer. And this is the general solution of the given first order first degree differential equation. So it is the complete answer or the final answer of the third problem. Then let us move towards to the fourth problem of this video session. So here it is, the fourth problem of this session, and let us solve it. So first of all we have to separate the variables here. So it will be e to the power x multiplied with the square root of 1 minus y square dx is equal to minus y upon x dy. And then we have to shift this term, we have to change the side of x and we have to bring back into the left hand side, and then we have to shift the term square root of 1 minus x square and we have to divide it on the right hand side. So it will be x e to the power x dx is equal to minus y upon square root of 1 minus y square dy. Then we have to go for the integration. Integrating both sides. We have minus, I have multiplied and divided a 2 here because you can see that in the denominator part there is a term 1 minus y square, and the derivative of 1 minus y square, it is in the form of a 2y. So let us take this minus sign towards the minus 2y, and here in the left hand side we have to put the formula of integration by parts method. So here the first function is x, the second function is e to the power x, because we have to go through the Euler rule, and here x is the algebraic function and then e to the power x is the exponential function. As the algebraic function comes first, so it is the first function. As the exponential function comes the later of the algebraic function, so it is the second function. And then we have to move through another step here, we have to apply the substitution method. So let 1 minus y square is equal to t, then minus 2y dy is equal to dt. Then x integral of e to the power x dx minus derivative of x into integral of e to the power x dx, and then their whole integral with respect to x is equal to 1 upon 2, and it will be integral of 1 upon square root of t, and in place of minus 2y dy we can put dt here. Then x integral of e to the power x, it is e to the power x, so x into e to the power x minus derivative of x, it is 1 integral of e to the power x, it is e to the power x, then outside dx, then it will be 1 upon 2, it is 2 root t, because the formula of integral of 1 upon root t with respect to t, it is 2 root t plus any constant, you can take it as c x e to the power x minus integral of e to the power x with respect to x, because 1 multiplied with e to the power x, it is e to the power x and its integral with respect to x. Then cancelling both 2's here, we can have root t plus c, and then just some of the simplification are there. X e to the power x minus integral of e to the power x, it is e to the power x is equal to, we have to put the value of t here, and the value of t, it is 1 minus y square, so square root of 1 minus y square plus any constant c, and this is your final answer of this problem. So this is the complete answer or complete solution of the fourth problem of this video session. That means we have solved 4 problems based upon the variable separable method, and in the next let us come to the next problem, problem number 5 of this video session, and it is given that dy upon dx is equal to 1 upon x plus y plus xy, and you can see that this is the first order and first degree differential equation, and this problem can be solved by using the variable separable methods. You can see the form, the right hand side terms are 1 plus x plus y plus xy, but we can separate them by taking or factorizing the right hand side. So let us factorize first of all. Then 1, taking 1 common from the first 2 terms, it will be 1 plus x. Then taking y common from the last 2 terms, we are having 1 plus x again. Then dy upon dx, it is 1 plus x multiplied with 1 plus y, and you can see that the terms having variable as x and also y are separated now, and now we can separate the both of the functions f of x and f of y in corresponding their operators dx and dy. So let us separate them. 1 upon 1 plus y dy is equal to 1 plus x dx, and then we have to integrate both sides. So integrating both sides, we have integral of 1 upon 1 plus y with respect to y, and then in the right hand side integral of 1 plus x dx. Integrating 1 upon 1 plus y, as it is a linear function having the degree 1 and also the coefficient of the variable is 1, so we can put the formula directly here. As the logarithmic formula here, it is log modulus of 1 plus y is equal to integral of 1 dx plus integral of x dx, and here integral of 1 it is x, then integral of x it is x square by 2 plus any constant, you can take it as c or k or c1, you can take any of the form of the constant, and this is the final complete answer of the 5th number problem, or you can see that the complete solution is here for the number 5th problem, which was given by dy upon dx is equal to 1 plus x plus y plus xy. It was not looked like a variable separable method, but whenever we are going to factorize the functions, right hand side functions, then we are getting two products of 1 plus x and 1 plus y, and they can be separated with each other, and again they are separated with corresponding their operators dy and dx. So this is the total 5 problems based upon the variable separable methods, and we have seen some of the fundamentals behind the variable separable method. That is, the fundamental behind the variable separable method is, first of all we have to separate the variables towards the two sides of the given equation, and it is a differential equation of first order and first degree. So, and then after separating the variables, we are integrating by using some of the proper substitutions or some of the formulas of integrations that we have already studied, and then we are getting the general solution of the first order first degree differential equation. So this is the complete solution or the notes of the variable separable method. In the next video session, we are going to solve some of the problems based upon the variable separable method from your Element of Mathematics Class 12 book. Till then, thank you.